Good morning everyone. Today we are going to study about drawing position time graph of a body moving with the first case positive acceleration, second is the negative acceleration and third case is the zero acceleration. First let's understand what is acceleration. The rate of change of velocity of a body with respect to time is called acceleration, or the acceleration of a body or an object is defined as the change in the velocity per unit time. It is of two types, or rather three types: positive, negative and zero. Positive is where the velocity increases, negative is when the velocity decreases, and zero is when the velocity is constant, means a straight line graph. This is an hint to drawing a position time graph of a body moving with zero acceleration. First case is positive acceleration. When the velocity of a body increases with time, its acceleration is positive. The first figure here we can see is an example of position time graph with respect to a positive acceleration. Here it is moving upward, indicating that the velocity increases. The position of object is changing with respect to time, and there is an upward trend in velocity. Two examples for positive acceleration. If an object starts from rest, means it is at rest, and its velocity goes on increasing with time in the direction of motion, so it is a positive acceleration. Acceleration on an object is positive if the direction is the same as that of the direction of the motion of the object, means the motion and the object's direction is the same. Second example, a body falling towards the earth has a positive acceleration. Any body falling towards the earth has a positive acceleration. If an object starts from rest and its velocity goes on increasing, means the velocity increase is the basic thing to define positive acceleration happening. Here dx by dt is greater than 0 because anything positive is always greater than 0. So the first graph is an example of ideal position time graph for a body moving with positive acceleration. The second one here we have is a negative acceleration. Negative indicates that the velocity is somehow getting affected. It will decrease. Negative means decrease, opposite of positive. The graph will be downward, means dx by dt of the velocity will be lesser than 0, means the velocity of the acceleration will be lesser than 0. That we can understand from a line that we have been studying for years. The second graph here indicates a negative acceleration. Here we can clearly see that the position is changing with respect to time, but the velocity is decreasing. We can see the downward trend in the graph. This indicates a negative acceleration. When the velocity of a body decreases with time, the acceleration is negative. It is also called retardation or deceleration. In this case, the while is the necessity of the moving body is less than the initial velocity, means the initial velocity is greater than the final velocity. It is clearly indicated from the negative acceleration. Negative sign indicates that the direction of acceleration is opposite to the direction of motion of an object. The first example is, if an object is moving with a certain velocity is brought to rest, then the object is said to have negative acceleration. When a ball is thrown vertically upward, means the ball is thrown up, its velocity decreases with time. So the acceleration of a ball thrown vertically upward is negative. This is a case of negative acceleration. The third case here is zero acceleration. We know that velocity is the rate of change of displacement with respect to time. If we are given that acceleration is 0, means a is equal to dv by dt is 0. Therefore, the velocity is constant. Velocity is independent of time and its slope is 0. So mathematically d by dx of k is 0. We can say that position time graph is linear. This is because we know that d by dx of kx is k. Since the position time graph must be linear, so the third case where the position time graph is a straight line, means there is a constant change in velocity. Not a change, it is the velocity keeps on being constant. There is nothing like an acceleration in this case, so it is a case of zero acceleration. Thank you.